and I now come to the last two sections of my lecture, and what I will call this as a war of currents towards solar DC. This is a very interesting story, and I came across it about 8-9 years back. First from my experience, and then I started looking at the history and I saw what is happening. What was the issue? I started to work. I used to work in telecom area. I started working in solar, electric vehicles, energy. That's the time I learned that solar power panel produces DC power. Of course, we use all 230 volt AC, so I have to convert this to AC power. And I was told there will be losses. For small panel, I wanted to do one for my home, small panel. The losses were quite high, 15% in that whatever solar energy was done, I converted into AC, 15% loss. I mean, that time the solar panel 8-9 years back was expensive, so it pinched. But I said, well, you can't do much about it. Then I found out that if I don't use the power immediately, I have to put it in the battery, excess power. Putting in the battery also takes DC power. So I have to convert AC back into DC. That is again 15% loss. Horrible. But what else can you do? That is how my first system was designed. Then later on, when you don't have enough solar, you will use the battery power. You will convert the DC power stored in the battery, DC energy, you convert it to AC. You will again have 15% loss. So I sort of say, if I go through my battery, I land up with 45% loss. Expensive solar panel, I am losing 45%. The worst was still to come. That is a time these tungsten bulbs and tube lights, which are all AC powered, was starting to be replaced by LED. Now, LED uses only DC power. So, what I was doing was taking AC, I was once more converting it to DC. So, there were 4 conversions, each time for small amount of power, 10 to 15% loss. It is at that time I sort of said, your source is DC, your storage is DC, your end usage at least for light is DC, why not keep it DC? Says, what will you do with other than light? Well, I know the electronics also uses only DC. So, all electronics can also be powered like that. Great. Fan was an exception, but then I quickly learned that fans are powered by AC induction motor, but if I really put a DC motor, my efficiency of the fan increases by 2 times, 2.5 times. So, I can make a DC motor fan. That is a time my own work started with solar DC. We will take solar from DC, we will put it into the battery into DC, take the power out as DC, put it to light directly as DC, power electronics, television, laptops, phones all directly on DC, and we made DC fan, brushless DC motor fan, which will drive the fan. And soon I found that our refrigerator also primarily is a motor that drives a compressor, that can also be DC. Air conditioner is also DC motor, can be driven by a DC motor. The refrigerator, the washing machine, everything is DC, can be gainfully driven by DC motor. So, I sort of say, why not use DC? My colleagues were not happy. faculty colleagues sort of said, "Wow, what are you talking about? This DC power issue has been settled 100 years back. You are taking India backward." I couldn't even understand. And then they pointed out to me this interesting story, and I will continue that, but first tell you about this, the war of currents. All of us know that Thomas Edison invented light bulb. We have heard it. 1880s, 120 years, 140 years back. But I don't know whether many of you know that he was a big promoter of DC power. He believed that the power produced should be all DC and we should distribute DC. There was another gentleman, another scientist called Nikola Tesla. Nothing to do with Tesla Motors, but Tesla Motors has borrowed his name. He was for AC power. These were two prominent scientists in the United States, scientists come businessmen. In fact, Tesla came from I think Europe somewhere. Edison was already set, he was producing DC power, doing everything DC, and somebody sent Nikola Tesla to Edison to work with him, and Tesla was kind of rebuked by Edison and then was ready to give him the lowest possible job in his company. Rebuked, Tesla moved out and said, I will do something different. He understood everything and became a promoter of AC power. And there are two scientists, two big scientists now, one DC, one AC, and they are businessmen associated with it, businessmen associated with it, politicians associated with it, the politician associated with it, and they fought, bitterly. Initially about merit demerit of AC versus DC. It has certain advantage, AC had a certain advantage. But once it becomes battles like this, where there are businessmen and politicians involved, it is no longer a technical argument. Soon the media will join, media joins, and instead of technical arguments, you started using all kinds of rumors and all kinds of things. They started talking, of course, the first thing they will talk about safety, but safety is also very often a game. In fact, in I think New York or Boston, they in fact actually had some animal, they electrocuted animal through DC and AC, which one kills first. And a lot of data was manipulated, data was not true, both sides were giving false data. In reading the whole story, I really, and it was very important people, both Thomas Edison and Nikola Tesla, we realized that once scientists are joined by business and politicians, how dirty things can become. And that, if you want to, you can study the whole thing, Google it, the war of currents, and I have taken most of the material from there. Tesla believed in alternating current was solution. Edison believed it was DC was a solution. And Edison came in first. He had also started installing DC lines and everything, started powering homes. And Tesla believed that AC will take care of it. For a long time there was no real good technical argument. And then all the power behind starts impacting. A new finally it was technically decided by something that got invented in Poland, far away from both these people, a transformer. What does a transformer do? What is a transformer? You have a primary winding and you have a secondary winding. By putting less number of turns and more number of turns, AC current can be transformed to higher voltage, AC voltage can be transformed to higher voltage or lower voltage. And it is a very simple device. This transformer was invented Hungary, Poland, somewhere there by 4 scientists. Quickly it was, all the things were taken over, patents etc. was taken over by Tesla. And he says, now I can send, in transmission on a cable there is a I square R loss, I square R, current square into R. So, if my I is large, my losses are large. I like to make I small. So, if I want to transmit lot of power, if I increase the voltage, my current reduces, it's the voltage into current. So, if I can increase the voltage, my current will reduce. Earlier DC power was transmitted 110 volt. Tesla said, what if I transmitted 1000 volt? Of course, earlier he was talking about how safe AC is, but he was not talking about much higher voltage, which is much more dangerous. So, but suddenly your current goes down by 10 times for the same power. Current goes down by 10 times, losses goes down by 100 times, I square R. This transformer clearly said for transmission, AC is far superior, and that decided the edge. It is a transmit. William Stanley developed a first practical AC transformer. This was developed practical AC, but Hungarian scientists, the team which never got what they actually developed, they are the one who developed. So, AC transmission voltage can be increased and then you can do this. This gave decisive technical reason why Tesla won vis-a-vis Edison, and the world moved to AC. Complete world moved to AC and remained with AC. AC long distance for transmission, AC for power distribution grid, AC at homes and offices, AC appliances, AC protection was perfected, and the work on DC largely stopped, and everybody thought DC is of no use. Some rumblings here and there, but 100 years, or I will say 70, 80 years, DC was considered dead. All the advantage of DC then gets pushed down. There are lots of advantages. For example, I just told you a DC motor is 2.5 times more energy efficient as compared to AC, and all these 100 years we have been using AC motors. This kind of thing happens in technology. To contending technology, one wins for some reasons. Is the other technology dead forever? Maybe, but maybe not. If one is careful, one finds that suddenly, for some reason, that will become very important. And in recent times, DC has come back. Why? Solar energy, wind energy is all DC, batteries are all DC, your usage LED is all DC, you put DC motor fans and DC motor in all the appliances, far less energy consumption more. And remember, in this situation where there is a greenhouse effect and we are worrying about that, if energy efficiency makes a huge difference, so everybody is moving to DC. What about transmission, long distance transmission? Transmission was only AC, except in the from around 2000 onwards. Power electronics. What is power electronics? Electronics, by the way, electronics was all DC. Electronics was transistors, televisions, computers, all were low power, 5 volt, 3.3 volt, 2.4 volt, 1.8 volt, 1.6 volt DC. They are all DC, but they are very low voltage, very low power. That is electronics. Power electronics is electronics. It has switching just like any other electronics, but it is a much higher power. Power electronics has been known for some time, but from around 2000 onwards, you started developing what is called semiconductor power electronics devices. MOSFETs were some of the early one, now IGBT, and suddenly they could be semiconductor, and therefore their cost will come down less like any other ICs, and the power electronics area became very popular. Now, even for high power, everything is converted to DC, because electronics remains DC and processed in DC domain and converted to AC if required. So, even long distance transmission, people are sort of saying, suddenly seeing advantage of AC, DC. DC has less losses, provided you can get DC at high voltage. Problem was, how do you get DC at high voltage? Earlier you could not get, and then how do you convert it back to lower voltage? Transformers do not work, and you came across what is called solid state transformers. So, what you do is you use these rectifiers and other things to convert it to a DC, and then do convert it to DC, convert to higher voltage in DC, and then transmit. This is something that we, and it is now known that minimum losses are in DC, not in AC, and therefore, long distance transmission lines, when we do across countries or from Delhi to Nepal, Nepal has a lot of very good waterfalls, so good hydel energy, and you have a huge transmission line from Delhi to Nepal, it is a DC. If you want to do it across countries, it has to be DC power lines. So, but lot of things were not developed, so you have to develop it afresh. So, diffusion of technology innovation highly dependent on market as well as government policies. As far back as 1930, all these things were known. In Madras archives, we found the government sort of said what should be used, AC versus DC. In fact, India in some places were continuing to use DC. Calculations showed that AC fan consumed about twice as much energy as DC fan. Government also feared that, however, they did not want a AC DC mixed, and they decided on AC. High voltage DC power lines suddenly has become the way to transmit bulk power. Even in medium power transmission, you can now get solid state transformers. Solid state transformers are basically made out of power electronics, and you do not do it by simply putting the winding cables across a magnet. The method is different, but you can get a solid state transformer. So, this is what has become DC quite common, and one is looking at it. Discrete electronics before 80s, expensive and less reliable. Integrated circuits came in late 70s. Moore's law kept on driving the cost down. You started doing programmable integrated circuits. Software is one time effort, India became dominant. Electronics all came, all electronics is DC, and all electronics today, you buy a normal television, it is a AC to DC converter. In fact, if you ask me a question, you ask any repair person, the maximum failure takes place in that AC to DC conversion. Why not use DC directly was important. So, everything moved from AC to DC. CRT, television, AC, plasma still AC, LCD was first DC, LED, all DC. You see microwave ovens used to be huge, AC 3000 watts, now you consume much less power and give you the same efficiency. Incandescent bulb, fluorescent light, CFL and LED, all DC. Reduced power consumption, reduced sizes, ease of use, reduced costs, all of them happens with DC. LED, lights, television, microwaves, movement from AC to DC. Electronics is anyway DC. DC was slowly creeping into homes. Stage was slowly setting up for DC power line. Bigger things were still to come and it is to wait. India used 72% of its domestic power on lighting and fans. So, motorized load, as I told you, is all DC fans, air conditioner, washing pumps. Energy efficiency, the consumption and energy efficiency of these appliances are largely dependent on the type of motor used. So, a normal fan at your home consumes 72 watts, a DC motor for fan consumes about 30 watts. We built this. And when you reduce the speed of the fan, AC will still continue to consume a lot of power. From 72 watts you will get it to 60 watts, this 30 watts will get to 10 watts or 7 watts. Magic came in terms of power electronics IC and change happened in the turn of the century. There were two people from India, IIT Madras alumni Jayant Baliga and Krishna Swamy played the key role, and power electronics integrated circuits came in, and with power electronics came Moore's law, and current switching moved from 50 hertz to 500 hertz to 5000 hertz. It was, you are doing switching at much higher frequency, that is the key, and then you can do conversion. You do not need big transformer, you can just do a tiny cutie transformer at much higher frequency. See, things smaller, more reliable, and variable frequency devices, BLDC motors, refrigerator, everything became DC. Net there is a strong case for DC power line at each home. I have talked about all this, but so we decided to make it a solar power system. My colleagues were not convinced for a long time. They still said that I am probably starting to get senile. I was turning close to 60, not yet 60 at that time. And they just did not buy any argument. This is what bias does.